Okay, so today's lecture is going to be on a lab that we're going to be doing tomorrow in class or on Monday in class, and it's called the G lab, G being gravity. So what we're going to be doing is we're going to be doing an experiment and we're going to calculate the value of gravity. Now we all know that the value of gravity is 9.8 meters per second squared. Some texts you'll see 9.81, and but what we're going to do today is we're going to assume we don't know it and we're going to calculate it. So we're going to take the original equation, and these are our kinematic equations, or our motion with constant acceleration equations. You know, the equations that are above my whiteboard. So this one we're going to be looking at is delta y, which is our displacement in the y direction, is equal to the initial velocity times the time plus 1/2 a t squared. Well, we know that if we drop an object, remember that key word dropped, we know that that initial velocity is 0. So what we can do is we get rid of this value right here, and then we have our delta y, which is our displacement in the y direction, equals 1/2 at squared. So now what we do is we're going to rearrange this equation and solve for our acceleration, and we end up with the acceleration as 2 times the displacement in the y over t squared. So right now, we know that we can figure out what this acceleration is. And we know from our lectures that the acceleration in this direction is always negative 9.8 meters per second squared. So that's really what we're calculating. So we can say that g equals 2 times the displacement in the y direction all over t squared. So what we're going to do in this lab is we're going to measure our delta y, and we're going to time the time for something that's going to drop from a certain delta y. Okay, so how are we going to do this procedure? Well, first off, we're going to take 3 different balls, okay? And the balls that we're going to be doing is a ping pong ball. So this is one of those light little ping pong balls. We're going to have a tennis ball, and we're also going to have like a playground ball, okay? So we have 3 different balls. The reason why we're doing 3 different balls is just to test the idea that things of different masses all fall at the same rate. So we're really going to be doing 2 things at once during this lab. So all 3 of these balls are going to have a different mass, and we are going to calculate that mass of the balls before we start the lab. So we're going to take 3 different balls. We're going to throw them from 2 different heights, okay? So we're actually going to drop them. I shouldn't say throw, because we're going to drop them, which means that their initial velocity is going to be 0 from 2 different heights. Now the 2 different heights that we're going to be doing, the first one is going to be on the balcony right outside building 3, and then the second one is going to be like on that middle ledge between the stairs. So we have 2 different heights. We're going to drop all 3 of these balls, and we're going to time it, do it 4 times. So each ball, this ball we're going to drop 4 times from the upper ledge. Then we're going to drop this one 4 times from the upper ledge, and then we're going to drop this one 4 times from the upper ledge, and then we're going to do the same thing at the lower ledge, dropping all 3 balls 4 different times. Then what we're going to do to find our value of t, which is our time, we need to find out how long does it take for that ball to go from one height to a different height, or a displacement of y. Well, we're going to use a stopwatch to get that value. That means one of the lab partners has to be at the bottom at the ground level to be able to start and stop the stopwatch. Now to find our delta y value, we're just going to use string, because our yardsticks are not large enough, or the meter sticks are not large enough. It would take us about 20 of them to go up that height. So what we're going to do is each group's going to get a piece of string, and you're going to drop it, and you're going to mark at the top the height that you're going to be dropping it from. From this piece of string, then we can lay out one measuring tape, and we can find out how long that distance is. Okay, and what we're going to do is after we figure all this stuff out, we're going to put it in a data table, and then we're going to be able to solve for our acceleration due to gravity, which hopefully should be around 9.81 meters per second squared. Okay, so what are we going to do as far as homework? What do you need to come into class with? Now, first off, our lab is going to be done outside, so get some comfortable clothes and the Florida heat, so you need to make sure that you're in comfortable and cool clothes. What you're going to need to do is you're going to have to download and print a hard copy of the lab. So you're gonna see under chapter 3, it's gonna say Gravity Lab or G Lab, and you're gonna download that and print that. Now, if you don't do that or you run into some problems, I will have some class copies, but you're gonna have to make sure that you won't be able to write on those, so make sure that you download it. The other thing is there's going to be a pre-lab assignment, and this is just going to help you understand a little bit more about the data that we're going to be getting. So make sure that you complete that pre-lab assignment. Once again, it's going to say pre-lab for gravity or pre-gravity lab, and that's also going to be in chapter 3. So make sure tomorrow that you come in ready to do the lab. Make sure that you have a hard copy of the lab so you can record your data, and also make sure that you've completed your pre-lab. Otherwise, we'll see you tomorrow and we'll be calculating gravity. Have a great day.